Hi everyone, so the problem I'm doing is from section 11.5, it's number 8, it's find the length of the spiral. R equals 3 theta squared from 0 is less than or equal to theta is less than or equal to the square root of 21, which means we're going to be using this cool little equation here to find the length. So first is the easiest part, you just find the derivative of 3 times theta squared, which, there you go, 6 theta. If only all of it was that easy. So then you just plug in variables into the equation here. You've got your r value here, and your dr d theta, which is 6 theta here, d theta at the end there. And that can be further simplified to 3 theta times the square root of theta squared plus 4 d theta. I didn't go through the steps for that because, I mean, you can eyeball it. So this can be expressed another way as well. Okay, so if we got the integral of f of v d theta, that's just another way of saying this, right? So the integral of f v is just, you got dv over d theta. So if you say that this inside of the square root is our v, well then dv d theta will just be the derivative of this. It'll just be d theta. So this can be rewritten or transformed, as my math lab likes to say, into this. This is equivalent. We're doing I don't know why they use a v instead of a u substitution, but v it is. So 3 theta times the square root of v over 2 theta dv. And then now we really have to take care of the limits of integration here because that's too tough to work with. But that's just, excuse me, that's just the length is equal to, now we've got it going from 25 to 4 to 25. And our integral is much easier to deal with. It's 3 theta times square root of v over 2 theta. And now we can just take out the constant here. So now we're just left with v, the square root of v, very easy to deal with. So that comes to this, we've got 3 over 2 times 2 over 3 v to the 3 over 2 power. I don't know why, this is so funny. I was like doing all this difficult math, I was like, oh wait, this is just 1. So plugging in your variables here, you got 1, 1, okay, it's just there. It's just 25 to the 3 over 2 power minus 4 to the 3 over 2 power. After we integrate, of course, I mean, that's what we're left with. And then we can just kind of disregard that almost, right? You just pop in the 25 here, 25 here, 25 here. So doing that simple math, that's just 125, right? That's 4. So the length would be equal to 117. I picked this example because, I don't know, it seemed kind of interesting to find the length of a spiral. I'd never seen this equation, but it seems kind of handy, right? The length being equal to the integral. This is supposed to be alpha and beta, I guess, is what my math lab uses. So yeah, square root of the derivative squared d theta. So yeah, pretty easy. I'll go through it again. You're just basically taking the derivative of the r value that you're given and plugging it into the equation. I skipped over this step a little bit, but I mean, you're basically just stripping it out of there. A million integrals do something very similar. And then rewriting it in this way, which I wouldn't have thought of had my math lab not pointed it out. So you can rewrite this equation using this formula into this. I'm saying that our v value is what's inside the square root, and then finding its derivative and sliding it under there. This is equivalent, these three. And then you're just taking the constant out. Oh, you know what? I forgot a dv. I don't want to get in trouble for that. I'm trying to be good. Okay, and then that pops out of here. The thetas cancel, I suppose. And then you find the integral. These things just kind of cancel out. Then you just pop 25 for, okay, 25 minus 4, 125 minus 8. So our length is equal to 117 from this function. All right. Hope it helps somebody. This is a problem, I think, the second from the last. So if anyone's struggling with this stuff, hope it helps somebody. Time to get to chemistry class.